Engineering is not merely about designing structures or systems. It is about solving complex challenges, pushing the boundaries of knowledge, and creating solutions that stand the test of time. We are delighted to welcome you once again to EIL Samvaad, our platform for engaging and insightful conversations with the leaders, innovators, and experts whose contributions have enriched EIL's legacy of engineering excellence, innovation, and nation building. Today, we have with us Mr. S.V.R. Subramanyam, Executive Director Technical, Engineers India Limited, a distinguished leader who has been instrumental in steering the company's engineering and technology development initiatives. He is a mechanical engineer with a postgraduate specialization in machine and equipment design. Mr. Subramanyam has been associated with EIL since 1993. Over the last 3 decades, he has played a key role in advancing EIL's capabilities in engineering analysis, piping stress engineering, vibration studies, finite element analysis, asset integrity assessment, and post commissioning troubleshooting, among others. Under his leadership, the Engineering and Technology Development Division continues to provide advanced engineering solutions for some of the most challenging projects across the hydrocarbon, infrastructure, strategic storage, and alternative energy sectors. The division's expertise spans seismic engineering, structural dynamics, finite element analysis, critical piping stress analysis, underground storage caverns, fitness for service assessments, noise and vibrational studies, and several other specialized domains. Sir, welcome you to EIL Samvaad.
Thank you. Namaskar, Praveen.
Sir, you started your career way back in 1993 and career in EIL, I mean. So, can you just tell us a little bit about your early life and experiences that led to EIL and so far your professional journey in EIL?
Yeah, basically, it's very surprising to know that I'm spent around 33 years in EIL and superannuating shortly. In fact, when I joined EIL, I came with some up and downs in my earlier career, but everything ultimately had turned into a good opportunity while working in EIL and had a satisfying role, satisfying experiences in EIL, working in a different complex problems. Uh, as I said, it's basically I belong to a place called Kakinada, which is in fact we have a plant GSPC there in
Yes.
Kakinada. Because my father had worked as a teacher, he is a science teacher, so we every 3 years we pack our bags and move to the new location. Adjusting to the new location, it's a bit difficult, it takes some time. By the time we adjust to the location, we move to some other place. So like that, in fact, I started my schooling at a place near to Ramagundam, where again EL is involved in our FCL plant. Up to 5th class, I studied there. When I moved to a next place, there I completed 3 years, 6th to 8th class. During that time in Andhra Pradesh, normally we used to have a two different of mathematics, which decides the future in subsequent future. So there used to be like a general mathematics and composite mathematics. So whichever mathematics we opt in the 8th, it will continue up to 10th class. So normally it is considered as general mathematics is normal mathematics, and complex math, composite mathematics is related to the three complex trigonometry and other things. So when I was in a place where I just started my 8th class, that time it was a village. So composite mathematics was not there. Generally, it is considered as whoever takes the composite mathematics, they will get into the engineering, and general mathematics will get into the other domains. So because of my condition, I could not take the composite mathematics because it was not available in that school. So then I continued with the general mathematics. That time I had not thought about the future. So whatever the situation permitted, I continued there. Then in ninth class, we moved to some other place. Since in eighth class, I took the general mathematics only, so I continued with the general mathematics in ninth and 10th in next new place. But the thing is, when I moved to that new place, I joined in a high school where there are 5 sections. First 3 sections are for the composite mathematics, other 2 sections for general mathematics. It is considered that the first section will be the very bright, and as it goes down to the fifth section, it will consider as a less knowledgeable people in that one. Since I joined in the middle of the session, so I had to go for the last section only. So there, everybody used to think that it is not a good department. It is not a good section. It is a useless section. With that concept, somehow I felt very uncomfortable there because I had a dream of doing mathematics very good. I mean, was a very my good subject,
Favorite
mathematics, and
subject.
favorable subject. So I thought maybe I adjust. So because of the circumstances, I adjusted to that one. Somehow I made few friends which are also came like me only, and having unsatisfying this one. But once after 10th class is over, then I thought I had to go into the engineering. So I decided I wanted to utilize the time between 10th class and 11th class to learn more about the composite mathematics. So for a 1 month, I took support from one mathematics teacher and learned composite mathematics. Then took a admission in MPC, that is mathematics, physics, and chemistry. After 12th class, again some situations arose that whether I will. There was uncertainty whether I will get into the engineering or not because of the government restriction. Gadget, because my father was in a teaching. So there was a sudden gadget notification that the retirement age will be reduced from 58 to 55.
Okay.
So the time the gadget came, my father was having only 1 month service to retire. He didn't have any plan to do. Sufficient time to do planning for the future. So that time there was the uncertainty that whether I will go for the engineering or not. But due to motivation from my maternal uncle and the support from other family members, somehow I continued, completed my 12th class. Then I took admission in engineering. In engineering also, to keep away from Hyderabad, took a place which is smaller place in Andhra Pradesh to pursue my engineering. There again, it's a cool life, and I had a good outing there, and I had a good academic background, and I had excelled well in the studies. Then afterwards, again that time there used to be no campus interviews, and that place being a small place, we cannot continue and search for jobs there. So I moved to Hyderabad and started searching for a jobs, and ultimately I got a job in one of the fabrication company in Hyderabad. The situation in companies, like whenever we started working, I used to have a boss I was working in a design engineering section. I used to have a boss. Whenever I go to him, he used to close his books to keep it a secret. So in that situation, I felt that I may not be able to fit here and learn more. And at the same time, I had to go to I was made to go to the remote area or 20 kilometers away daily in a scorching heat of 45 degrees centigrade in a Luna. Then I felt it is better to leave the job and get into the new job. During that time, I got an opportunity to work as a project associate in IIT Madras. And there is a sudden change from industry to the academic area. The project associate is like just like a scientific officer, which we call in other sections. We have to do a research on a particular topic which was decided at the earlier. It is a contractual appointment for certain period. Though it is a contractual appointment, to get out of the Hyderabad, I chose this one and entered IIT Madras as a project associate. During that process, I started looking at the people pursuing BTech, MTech, and PhDs, and the people who are like project associate like me. They are also doing some higher study courses. Then it motivated me to again reignite my desire to do the post graduation. Then I wrote entrance examination gate and got a gate score. Then the time when it was about to join the MTech or MS, then I felt already I spent around 3 years in IIT Madras, so it is better to explore other IITs elsewhere. So I got admission in IIT Kharagpur and IIT Delhi. So for getting the admission in IIT Delhi, I had to attend an interview prior to the admission in Delhi. So I saw the campus of IIT Delhi. When it come to the IIT Kharagpur, initially I thought to go to the IIT Kharagpur. I went there. Then I realized that I may not fit it. I mean, because after seeing the IIT Delhi campus and the ambience, probably I felt I may not sustain in the IIT Kharagpur campus. So I decided to come to the Delhi. Immediately from Kharagpur, I moved to Delhi and joined IIT Delhi MTech in machine design. When I joined at that time, also some anxiety will be there. Anxiety was there because I am coming to a new place, and after working for 4 years, I am coming to the education. So, but one confidence I had is whatever work I had done in IIT Madras is similar to the academics only. So, with that confidence, I pursued and topped the class. Then actually one time destiny, it depends on the destiny. Doesn't mean that it is always negative, but it will give a positive results also. So during, I mean, when I was doing the MTech, I applied for a campus interview for Engineers India Limited.
Okay.
Then that time we were called at Bikaji, the interviews were held at Bikaji place office, but I didn't get the call letter. Initially there was a suspicion that why they rejected me, because then I asked my friends, they said they got the call letters, and I compared because my CGPA is better than them, why I didn't get the call. Then I decided to check, because what factor led me to, led the exclusion of my name in the interview call letter. So that time I know one of my friend was in EIL. I came to Bikajigama place and went to HR asking that I didn't get the call because I have a better CGPA. Then after scrutiny of the document, they said you are overaged by 13 days, because the cutoff date was 30th June, whereas you crossed the required age limit on 17th only. So that's why I missed it. That time I felt very bad because I missed the opportunity, but it led to a greater opportunity later. There was advertisement for senior engineer in ETD department. So I applied and got the admission, got the offer in November. The joining of EL is also not a simple one. It was a dramatic. When I started from Hyderabad to come to the Delhi to join, there was a bomb blast in the train, just that bogie which is preceding my bogie. There was a delay, but I didn't tell anybody. I just continued my journey, came to Delhi and joined EIL on 8th December 1993. That's what my journey has done. All these, all our different situations arises during my process.
What an incredible journey, sir. From Kakinada to Hyderabad, moving to IIT Madras, and then to IIT Delhi. Uh, you did not get selected initially in EIL, but later got an opportunity to, to work as a senior engineer itself in EIL, and from there, then to 2009, when you became HOD of the ETDT department, one of the specialized departments in EIL. So, as an HOD of EIL for almost 18 years, so for those who do not know much about the ETDT department, what it does, can you elaborate a little bit about what EIL's capabilities in terms of engineering analysis and the pertaining to ETDT, both for our internal stakeholders and our clients?
It is true that some of the departments in EL may not be knowing about what ETD does.
Correct.
For all of them, basically the ETD is called Engineering and Technology Development. It started as a division in 1981 in EIL. That time most of the engineering departments were part of the ETDD,
Okay.
like rotating machinery, geotechnical, electrical instrumentation, structures. Everybody used to be in ETDD division.
Okay.
So afterwards, slowly the departments moved to the engineering, and finally left with. I mean, during that time, actually, the present ETDs used to be called as ETD analysis group. This group was formed to give the specialized engineering services to the other engineering departments under ETDD.
Okay.
Once the engineering departments moved to their respective engineering division, there used to be only the geotech and advanced electrical and instrumentation. They used to be under the ETD. Slowly, advanced electrical and instrumentation moved away from ETD. Then geotech moved away from ETD and made it as a part of engineering. So with that, actually, only ETD analysis was left with ETD division.
Okay.
During 2008, since only one department was there in ETD division, they felt that the department also, because the ETD work mostly does for the engineering departments, so they felt that the ETD analysis also should be part of the engineering. Like that, we merged into engineering in 2008. Since then, we are in engineering division. The ETD basically is a specialized department. Wherever the regular engineering departments have a requirement of advanced analysis and they struck up somewhere during their regular design process, then they approach ETDD for advanced solutions, advanced analysis like finite element analysis, which only ETD does in the EIL. Similarly, any troubleshooting is to be done at the sites related to any vibrations, stress failures. In such cases, ETD involvement will be there to visit the sites, study the problem and give the resolution like that. And also we, over a period of time, ETD has moved into new domains, coke drums, double wall storage tanks and other things, and develop the capabilities to work in these fields. And wherever these requirements come, obviously the name comes in the mind is engineering and technology development. And we are working on the vibrations and other fields, new fields also now, like that fields like defense, in nuclear, where the advanced analyses are required. Their major role of ETD will come into the picture.
Yes, you talked about nuclear energy. So my next question would be related to that only. Sir, EIL has penetrated in nuclear energy sector recently, as like, we have job order book pertaining to the nuclear energy sector is around maybe 100 crores and more, and you have been the you have been part of the journey, in the last few years when we got so much of a nuclear energy job and the advancement in the sector, like the fast breeder reactor got criticality in, Kalpakkam fast breeder reactor, and SMRs are also coming up. So how do you see this sector growing, and role of EIL, particularly the role of the EIL's specialized division like ETDD, uh, your last job in the nuclear sector, and now how is the the challenge, and how to, how you are solving problems for the sector. So can you just explain a little bit more about it?
Yeah, as you know, actually, as far as the nuclear is concerned, it is not new to the EIL. In fact, we entered into the atomic energy sometime in 1980s. Since then, we EIL had worked in around 40 assignments in different roles. Either it is in the offset and balance of plant, or it is in the EPCM mode. Also, in some of the projects we worked in EPCM mode also. If you see that journey, but only the thing is like we had gaps in between, because 40 jobs in more than 40 years is like not like we are not working on the continuous basis, but there are gaps because of the one or other reasons. When we are bouncing back again, there used to be a gap. Like that it happened till 2021. Then it was in 2021 it was decided that we have to pursue the nuclear, because now there is a target of 100 gigawatt from
Yes.
the government That too by 2047 we have to complete 100 gigawatt. At present, NPCL is having, I mean, in India we are having only around 9 gigawatt power, and is already in operation, and the plants which are under construction may give another 9 gigawatt. At the most, it total may come to the 20 gigawatt.
True.
Now we have to fill the gap of 80 gigawatt. For 80 gigawatt, there will be tremendous work because the target is up to 2047. So there will be tremendous work to do, and the involvement of so many departments. I mean, so many departments and so many companies.
True.
Then only we will be able to achieve
Meet
100
that target.
gigawatt. So in that, with that in mind, EL has also thought that we should pursue it very seriously and get into the nuclear business. And as being a consultancy organization, reputed consultancy organization in other sectors, so it is, and also we had experience in nuclear earlier. So we thought that we should enter at a right time and contribute ourselves into the nuclear growth in the company. I mean, in India. If you see, like, probably most of the people might be knowing about the various technologies available in India about the nuclear, but just to give a glimpse of it, normally we have most of the, I mean, except one plant in India, all other plants are operating on pressurized heavy water reactor concept, where natural uranium is used and heavy water is used as a coolant. So what happens is I mean, out of 9 gigawatt, we are having almost 7 gigawatts are based on the pressurized heavy water reactor. Then one more concept has come, but these pressurized heavy water reactors, they are basically developed by NPCL, and they have generated the capability over a period of time. They started from 160 megawatt per unit to the 700 megawatt unit. So this journey was almost 30 years journey, and they developed the capability with the help of Baba Atomic Research Center. Now they are successfully executing 700 megawatt units in India. Because of the scarcity of uranium, it is felt that we should go into the light water systems. So in Kudanukulam, the concept is on the light water system where the enriched uranium is used. But the import of the enriched uranium is, we have restrictions in importing the uranium, I mean enriched uranium directly. Now after that we have, after uranium, basically we have a lot of thorium reserves. To utilize the thorium reserves and sustain in the near future, it is felt that we have to develop a capability in thorium research reactors.
Sure.
So with that concept, with that idea, the thorium reactor, a prototype thorium reactor at Kalpakam, that is fast breeder reactor, is come up. Now it has gone into the criticality. It gives it indicates that it is successful. So in future, we will have this facility continuously.
And sir, we have also been engaged for the development of Bharat Small Modular Reactor in line with the SMRs that is called globally. So can you throw some light on that as well? EIL's capability, and because in the coming years, SMRs will be greatly deployed to solve the power related challenges of the industry. So can you just tell us more about that also?
Yeah, actually, as per the concept, the small modular reactors are called, which are having up to the 300 megawatt. For the more than 300 megawatt, it's a large reactor. But there are some companies which they are developing about 450 megawatt. Still, they are claiming as it as a small modular reactor. The concept, I mean, the purpose of SMR is like in industries, because what happens is in industries we have a captive power plants. To phase out the captive power plants to reduce the carbon footprint, we require a nuclear power which is clean and green. For getting nuclear power to the plants, so they have to deploy a small modular reactor, because they don't require the capacity of 700 megawatt. So they require a small modular reactors. In that, for that purpose, the concept of small modular reactors come into the picture. If you talk about the small modular reactors, there are around 70 types of technologies are available worldwide, but only 4 have come to the stage where it is tested now. Only 4 reactors are operating elsewhere in the world, but majority of them are in the design stage or in the conceptualization stage. With that, and one more thing which we have to keep in mind is like going with small modular reactor alone will not make the bridge the gap of 80 gigawatt. So to take care of 80 gigawatt, it should be both SMRs and large reactors have to be deployed together. Then only we'll be able to achieve that target. So anyway, the large reactors will continue to come up, but apart from that, in place of CPPs, we'll go for the small modular reactors. In that direction, in fact, now NPCL with the support of Baba Atomic Research Center, they are working on small modular reactors. They are roped EIL as a consultant for design and conceptualization of the reactor and subsequent design of that. So now the small modular reactors, and not only we are working on 2 jobs where one is related to the small modular reactor based on the light water systems, and one more small modular reactor based on the heavy water
Heavy
system.
water system. Okay.
So we are, for the light water system is concerned, we are involved in the conceptualization, whereas for the heavy water system, we are working on the structural design, and after that we'll get into the mechanical part of the SMR.
As we are seeing the volatility in the global energy markets, so strategic storage of crude and petroleum products are becoming more important, more relevant now. And EIL have been involved in the construction engineering of the strategic storage caverns for petroleum crude oil as well as petroleum products. Recently, we commissioned the 80,000 metric ton LPG storage cavern for HPCL. And the role of specialized engineering departments like ETT is more there, because that was the deepest and the largest in terms of capacity as far as the storage of crude and petroleum products in the caverns are concerned. So what exactly, can you tell us more about what are the engineering challenges, or based on the geological, so what exactly goes in there, and what is your role as a department, and how it is kind of how is it solving the uh, as more strategic storage caverns would come up in the future. So I believe it is more important for us also to bridge any technological gap that we have. So can you tell us a little bit more about that, sir, about strategic storage part?
Actually, strategic storage in India started sometime in the early 2000s. The first LPG cavern was built by L&T for HPCL in Vizag. Afterwards, the SPRL, the Strategic Petroleum Reserves Limited, they had a plan to construct 3 caverns for the crude oil storage. Like that, it started the journey there, and EL was involved in all the 3 projects. That time, actually, it started from the Vizag plant. Then the second unit came up in Mangalore, and third unit is in the Padur. Whereas for Vizag and Mangalore, EL acted as a PMC. Did the basic engineering and the PMC. Whereas for Padur plant, EL involved in the detail engineering also. As you know, normally what happens is in the cavern projects, the main role comes from the 3 disciplines as far as the underground is concerned. One is geology, hydrogeology, and rock engineering. So in most of the caverns engineering, if you consider the underground part, the only these departments, these disciplines will be involved, and other disciplines will have some say, but majority is depending on the geology, hydrogeology, and rock engineering. Like that time there was a group called subsurface group, subsurface division, that it used to contain the project and technical departments also under the same umbrella. After completion of these 3 projects, around then ISPRL planned for the phase 2 extension of that. In that, apart from the crude, they are also planning, I mean, apart from the rock caverns, all these three are on the unlined rock
Online
caverns.
road, yes.
So in the phase 2, what ISPRL planned is, apart from the unlined rock caverns, they want to explore the salt
Salt
caverns,
caverns, yes.
which are abundant in Rajasthan area,
Bikaner.
Bikaner. So in order to take care of that, then they started the DFR for the phase 2. They identified couple of places and started DFR for those areas. And afterwards, due to the market and it bugged, I mean, it stopped for some time. Then the requirement of LPG has come into the picture. HPCL, because LPG will not be taken care by ISPRL. So HPCL, they wanted to construct a LPG cavern in Mangalore area, in their marketing terminal at Mangalore. So when it job, I mean, the concept what they thought is, because EIL is not having the entire design capability, there was a class that we had to engage a third party foreign backup consultant to do the basic engineering and detail engineering, and I mean majority of the basic engineering and detail engineering to some extent, so that EL can continue with the balance of detail engineering works. So we engaged a third party for that job. Uh, in fact, when this LPG cavern has come to the EIL, that time that subsurface group which was earlier with projects, that got merged into ETDD in 2015. So this job role of ETD is more in LPG cavern, because that technical group is with ETDD. So we started the job in LPG. We appointed a backup consultant, but what happens is, obviously it's a foreign backup consultant. We have to listen to them, and sometimes the site, as a construction progresses, whatever site issues come, then it has to be resolved by local company only, that is EL has to resolve. So coordinating with third party consultant has become little bit difficult. So sometimes, because of whatever experience we gained during the initial phases, we started optimizing the system and convinced the foreign backup consultant that this is the best system which suits for the Indian conditions. In fact, it was accepted, then we had done that one. During that time, during that phase only, HPCL wanted to have another LPG cavern. DFR was carried out for that also as an independent, I mean, without taking the foreign backup consultant. But that job has yet to come, because of the other constraints. HPCL has put it hold for some time now. Now, the present, if you see the present war conditions, the requirement of LPG has become very prominent.
Yes.
Uninterrupted supply of LPG is important. So, government is thinking to put a more and more LPG caverns now. Earlier, it was thinking to have a crude caverns, but now they are planning to have a LPG caverns also. So in this, apart from these caverns, actually in the ETD is basically developing a lined rock caverns concept. That is, till now we are having the unlined rock caverns. So whatever natural rock formation only we are using, now we can put a concrete layer over that to make it a lined rock cavern. This is more useful for the storage of high pressure gases like hydrogen and hydrogen, especially hydrogen. So what happens is, this concept, this is almost on the advanced stage. Probably we may have to put into the use after maybe a couple of months, then we can roll it out.
Sir, it was interesting to know how ETD division evolved from solving engineering problems for internal disciplines to detailed engineering work of the underground caverns. Can you tell us little more about the applications of these tools in the design of heat and mass transfer equipment and uh, storage technologies for cryogenic storage, like for storage of ethylene in divided double-walled storage tank like this? So can you tell us more about your experiences and the technology that was developed under you?
First, I will speak about the coke drum technologies.
Okay.
Normally, coke drums EIL licenses the coke drums also, DCU units. Uh, but over a period of time, as the capacity requirements are increasing, then we started, we started engaging a third party, licensor for DCUs. The first such plant has come up in Bina, where DCU unit was licensed by Lamas. So the design aspects, whatever we were doing earlier for the Numaligad or Digbai, they were of the smaller diameter, and the thermal analysis requirements are different. Whereas when it comes to the bigger reactor, bigger coke drums, around 9.5 meters around. So your thermal analysis will have a more advanced, we have to get into the advanced phase of the thermal analysis. And the licensors normally they don't give the calculations on the analysis calculations. So when we are, as you know, the coke drums are subjected to the cyclic loading and they are prone to the failures at the, especially at the shell scud junctions. But when we want to see the life, because as is a regular practice is that every 4 to 5 years they have to inspect and see whether there are any failures in the welding joints, then they re-weld it and put it into the operation. This is unavoidable, we have to do that one only. So to calculate, estimate how, how long will it work in a single go, that became a very difficult, because the licensors will not share the information with us, and what parameters they are taking in the calculations, those are also not documented in the codes. It is basically with their experiences they are taking the factors. So we thought when we are doing the Bina, when licensor was giving the calculations, we have started reviewing the calculations. That time we thought, why not we developed our own method capability in taking the, estimating the life of the coke drums and other stress calculations. So we started and we were trying to replicate the licensor calculations, and we were getting some variations in the values, in the results. Then we felt whatever assumption, whatever factors we are taking into the calculations, probably they are not matching with the licensor calculations. So that's why that variation is there. Then how to bridge that, then we started doing the sensitivity of the analysis, and we arrived to the calculations which are almost came close to the licensor. Then we started developing the capability in that one, and afterwards HMEL has come. And in fact, when this was put into the operation Bina, it had a problems. There was a failure in the beginning itself because of the wind, and the designs which were done probably had some factors they are not keyed in. So because of the winds, and there was a failure of the anchor bolts. That time EIL was called to the site to be, I was privileged to be a part of that group who visited site. We stayed for a long time there in the site and solved the problem. We observed the problem because it was new to us. Then it was not only the ETD, it was a multidisciplinary team was engaged in the site, and we started looking into each and every problem, what is going on and where the problem is. Then we dig it out and we started doing the analysis, back-end analysis. Finally, we identified what could be the problem. Whatever learning we made in Bina, we came, and that time HML was in construction stage. Then suddenly we came to HML, we audited the HML DC unit and find out what differences are there. Then we tried to erase those differences and make HML work properly once it puts into the operation. Fortunately for HML, we didn't face these problems. Then again, that time other units are also going on. Then we went to other units. We checked there and we ensured that whatever learning we made in Bina, that should be implemented in other places. Fortunately, all other plants are running fine now. And when it comes to the, as far as this one is concerned, the coke drums was concerned, it is basically a banana effect, which normally nowhere it is documented. Each licensor will have different banana effect values that has to be taken care into the piping analysis and the equipment structure analysis. So all these things we are documented and put a guidelines so that others in EL, the other departments like SMED and other department, they can see, and during the design stage they can follow those guidelines to have a better designs. Then apart from the programs for the storage of cryogenics, double wall storage
Storage
tanks
tanks.
concept is there. Normally there are two types of double wall storage tanks. For certain materials, basically for certain products you will have a double wall, but both walls will be of the steel construction. Whereas for the cryogenic applications we have to have a outer tank is a
Concrete and
concrete and inner tank is a steel. I mean earlier the most of the all double wall storage tanks were designed by the licensors, and they were giving the I mean they were not, I mean they were giving the designs and it was implemented. That time EL was involved in one or two jobs as a to review the documents, not to enter into. So similar to other, here also getting the information from the licensor or contractor will be difficult. So it took long time for us to develop the capability, and slowly we started learning. I mean we started learning what is there in that capable design of those systems. Then we learned those techniques and started developing. Now we have now we full-fledgedly we are working internally all designs, and in HML in fact we got it vetted by the licensor VESO. He vetted our design. So now we are doing in almost to all petrochemical plants and LNG plants. Double wall storage tank design is with EIL.
oh, that is great, sir. So, sir, that is giving me a hint like we have so many technologies under the umbrella of engineering technology division, and we have implemented it at various locations as well. So when it comes to technology development, is it's one side. Another part is the troubleshooting aspect. So you have been involved in multiple projects, I think, for post commissioning troubleshooting, vibration analysis, piping stress analysis, and then suggesting improvements or the solutions to various clients. So tell us more about it, because it is more important for overall plant integrity assessment as well. So tell us more about it, some of your jobs and earlier experience, and then recent experience, because it is relevant to the decarbonization initiatives as well. So sir, please.
Yeah, I mean, I joined in 1993, but within 1.5 year, I was asked to go to a site offshore platform. That was my first experience. In the earlier stages, most of the visits were made to the offshore platforms, where offshore platform is little bit difficult because the accessibility of the platforms is depending on the choppers, and once you are there you cannot move out from that place. You have to stay as long as you have to resolve the problem. Then only you can come out of, and there will not be any other obligation activity there except seeing the sea and other equipment there. Initially the problem which came is related to the vibrations and noise, and similarly that time it came to the reciprocating compressors, reciprocating pumps problems. In fact offshore platforms will not have any reciprocating compressor, it's a reciprocating pumps which were having a vibration issues. That made me to get into that problem. Prior to that, in fact we had a plan to develop the capability in acoustic analysis of the reciprocating machines. Normally what happens is the acoustic analysis will be done by the contractor. He will give it to the specialized agency. Normally it is kept in his scope only. So obviously EL was not having any capability in that one.
Sir, little bit more about acoustic analysis. What
Yeah.
is it?
The acoustic analysis is nothing like a pressure pulsation variation.
Okay.
What happens is in the reciprocating machines, when it gets operated, normally there will not be any continuous inflow and outflow from the reciprocating machines. Whenever the section valve opens, the flow will be there, then it will fill the cylinder, then afterwards section valve will be closed, then discharge will be opened, then flow will get out of that cylinder. In the piping, whenever the section, suppose during the section opening, that there will be a flow from the section piping. After that there will not be any flow. Similarly, in the discharge side, whenever it got discharged, that time flow will be there, then it will be ideal for some time. So this will cause a pressure pulsations in the system. Those are called acoustic analysis. Normally in the earlier days, what they used to do is they used to simulate a electrical system to predict the acoustic pulsations in the system.
These are under the scope of vendors.
These are under the scope of vendors. Normally, that's why the name of analog study used to be there in the earlier stages.
Okay.
Analog study is basically the pressure pulsations they identify through the electrical system. They pass on the current and see the voltage wave fluctuations. With that, they will convert it back to the mechanical parameters and say these are the pulsation levels generating in the machine. Afterwards, digitalization has come. Now we are doing the digital analysis of the system. So now it is called just acoustic analysis. So because of the non-continuous operation, non-continuous flow, there is a chance of generating pressure pulsations. That is the fluctuations from the main pressure. That pulsations will have an impact on the valve bodies in the compressors. Similarly, will have a pulsation generated will create additional forces on the piping. So the concept like the acoustic study, analog acoustic study will be done by the vendor. Then piping analysis will be done by the engineering consultant. This piping layout will be supplied to the contractor, and contractor using machine, I mean the contractor means it's a supplier of the machine, that he uses the machine characteristics and integrates with the piping. Then he calculates the mechanical study and identifies what are the pulsation levels both in machines and the equipment in the piping, then gives the recommendation how to control it. Then during 1993, it was thought that why can't EL develop this one, because the limitations which they were having that time is because if it is offered to a contractor, then he will give it to a specialized agency. There are only few specialized agencies are involved in the analysis. So once it goes to them, it will get into the queue, then the analysis gets delayed. In case if any changes occur during at a later stage, again redoing the analysis, again you have to go to the same agency and get it done, and during that time again it will be put it in the queue. So to avoid those delays, it is decided that we should develop our capability. The only issue there we got it like most of the analysis, I mean most of the development we could do, but there are some critical parameters which are proprietary in nature. So we couldn't get those properties from the compressor vendors or suppliers. Then ultimately we had developed to some extent and stopped it. But that development, that knowledge, whatever we gained during that process, that we could apply in the latter projects is, though we couldn't do the job, we couldn't do the analysis, like one in HMEL, they did the analysis, afterwards some line sizes are changed. Then again to redo the analysis, we had to go there, it was, I mean there was no much time to do that one. Then what we did is, we did the qualitative assessment and gave a clearance for going at the design. So this, as that whatever knowledge we gained during that time process, that has helped us to take the quick decisions. Even most of the jobs we do in a similar way related to the acoustic pulsations.
Okay, so this must have required advanced engineering tools. So sir, in 1990s, when you started your career in this field, and now, so how do you think this transformation, like the application of tools, new tools, must have been coming gradually, and adaptability of our engineers to that tools? So how has it been useful to us? Or right now, I must say, like EIL has most advanced tools in place. So what do you think, how it is, kind of, how it happened? So did you face any challenge in implementing those in EIL, or the advancement of tools, did you have to kind of adjust your calculations, or did you face any difficulty in that adopting that new technologies from the earlier ones that we were using?
Yeah, in fact, during those days, if you see the situation, like couple of people used to share one PC.
Yes.
We used to have limited software resources and only those softwares, because I mean these are also based on the analytical calculations. This software was developed, and we didn't have any tools to do the advanced analysis. As the time passes, now the softwares also equipped with the advanced analysis. They have increased, and the I mean, we are getting the high-end computers, which running capacity has, I mean, the memory has increased, and these things had helped us to transition from that analysis to the advanced analysis. Now, in fact, maybe in the initial stages we might be having one or two issues, but over a period of time, whatever issues we had faced, we could mitigate and get on with the analysis. In fact, it may be surprising to know that now we are giving guidance to the supplier, software supplier, if any problem comes. So that capability already we
Achieved.
developed and achieved, and we are now, of course, digitalization has come into the picture. In fact, for program thermal analysis and life estimation, we are almost at the verge of developing. I mean, we have started developing, then it is about to complete also. We are developing a digitalization concept using AI and ML to estimate the life of the programs with the help of DTS department.
So the digital twinning is possible now
Yeah,
with the
it is
help of these
possible.
advanced tools and use of AI. So I
Mm.
was coming to that, how you are leveraging AI into your systems.
Yeah, in fact, we are using AI in our systems. I mean, whatever systems we developed earlier. In fact, ETD, though it is not a ITS and not under ITS, we used to develop softwares for the use of other engineering departments using the tools available then. Now we have to integrate. I mean, we have to migrate. I mean, develop those. Tools. We have to use those tools for the latest technology and the latest course. Whenever we are upgrading the software, we are trying to use the AI. And in fact, few people are there in expertise in AI. I mean, they have got expertise in AI and ML in our department. They are working on this, and hope in future we'll be able to implement in more and more tools.
Sure, sure. Great, sir. So, after completing almost 33 years of your journey in EIL, so what message would you like to give to young engineers who are willing to join the core engineering field, or the field engineering technology, uh, the tools which engineering technology divisions are using, and they are interested in using those in their, or making it as a professional career in core engineering department? What is your message for the young engineers?
Yeah, prior to that, actually, I have to acknowledge that whatever success myself and the department has achieved, it is basically with the support of higher ups, my earlier bosses under whom I had worked, and my subordinates, the teammates in the department. Without their support, it is impossible to get this success. I owe to them, and in fact, whatever success we have achieved in ETDD, that is because of the nature of the work we are doing, because we are supporting other engineering departments, and because of that, normally what happens is the interaction with other departments used to be very cordial, and in fact is developed a personal relations with others also. Whenever I go to other department and talk to some person, the other neighborhood persons will get into the discussion and they become a friends also. So I felt that personal touch is very important in consultancy job, because we have to work together. Maybe each one is good in their capabilities, each one has their own domains, but when it comes to the company delivering the projects, everybody has to work together in a similar cordial relations, then only we will be able to. There may be a difference of opinion, but when it that can be ironed out with the brainstorming and discussions, then definitely we'll do it as a this one. The other one is, what I'll tell the youngsters is, like, when you're getting into the technical this one, you have to adapt to the new technologies, new domains. Like at present, nuclear seems to be a new domain for AI, and defense jobs we are doing. So we have to quickly adapt. We are working in a different projects, different domains. But when it comes to the new domain, we have to quickly adapt to the new domain. May take some time in the initial stages, but we learn over the period of time. Once you do one job successfully, maybe a little late, but these will help you doing the jobs in the future. That's what I want to tell the youngsters. So be focused and be flexible to get into the new domains, and you have to adapt them the technology.
Sir, you spent more than 3 decades in EIL. So, can you tell us about your what do you think about EIL's future business trajectory and growth, maybe in next 10 years?
Yeah, actually, if you see from the beginning, 1993 to 2026, there are a lot of changes in the systems, and because of the generational changes, the people who are coming in the new generation, they are having more and more adapted to the software tools and high technology options are there. I think probably we are basically changing into the new system, and what advanced analysis also we would be able to do because of the new tools, and new youngsters are more eager to do that one. So with that, I think probably, and that is visible now in the order book we are having in the last few years, and the way we entered into the new domains may not be a new totally, but it's a re-entry into the domains, like new
Diversified sector, sir.
diversifying and re-entry into the nuclear and other domains. Obviously, I wish that EL will sustain in that one, and with the people who are around now, obviously, we, I think will success in the future also, and we'll get more and more jobs in these sectors. Obviously, the oil and gas is still there as our core business, but apart from the core business, we'll have more business in the other sectors, and I am very sure that the manpower which we are having now, maybe few of may be retiring, but the new generation which has come, they will take forward the legacy given by the older comers.
And sir, on personal front, what is your future plans after retirement? What we are going to see or witness you in which role in the coming years?
Yeah, I mean, of course, as I said, I may have to take some rest for some time. But the fields which I have garnered, like vibrations, I mean, troubleshooting, and working in a nuclear domain for the last 4 years, pursuing with the clients, these have ignited me to pursue in a new domain. So obviously, I will see wherever this one is, then I will get into those shoes. Will try to get more and more satisfaction in those fields.
Any plans to move into academia or you want to
At
remain in
present, I
industry?
don't have any academic plans, but let's see, because I don't have the. I mean, the one factor which I forgot to tell is, whatever satisfaction I had and the people who are with me in ETDD because of their qualifications, though I am not a doctorate, I am a postgraduate only. I was warmly called as Dr. Subramanyam.
Yeah.
That made me very satisfying. So Maybe I may have to justify that doctorate.
Anyway, your family member, one of your daughter is becoming a doctor now, I think.
Yeah, she is pursuing her PhD in e-transfer from Purdue University. She will be completing another couple of months, so she becomes a first doctor. I mean, actual doctorate in our family.
Thank you so much, SVR sir, for sharing your valuable insights and experiences with us today. Your remarkable journey exemplifies the spirit of technical excellence, continuous learning, and innovation that defines EIL. On behalf of EIL family, we thank you for your leadership, mentorship, and enduring legacy and wish you happiness, good health, and fulfillment in the years to come. Thank you so much.
Thank you very much. Thank you for giving this opportunity to express my views and talking on the different topics. Thank you once again.
Thank you all for joining us on this episode of EIL Samvaad. Stay connected as we continue to bring you inspiring conversations with the leaders, innovators, and visionaries who are shaping the future of engineering and contributing to the nation building. Until next time, keep innovating, keep learning, and keep building a better tomorrow.